Hi there, this is Bill Foot, week 4. You've caught me in the middle of expanding on the reading model of multi-period production. Glasses are tipped down so I can read my screen. Um, and I thought I would just kind of let you follow along with my own trials and tribulations in putting this together. This is the case. This is a case walkthrough. Let me show you what I've done up to this point. I'm going to share my screen now. And let's remove this. Yes, it's 9:52. Finally getting to this. Okay, this is where I've gotten to so far. I don't know that this is going to work. Usually it does. The first thing I did was I dropped the demand analysis from week 2 into um, my multi-period production. I'll call it expanded version 1. And you can see we have slightly different versions of the truth from week to week. Week 1, we had a different A0 or intercept and a different slope. This week 2, we have this. We can change these at will. We can even put a slide bar in. You will find it's not so easy to automate solver. We will do an automation of solver in what we're going to do. But for right now, we dropped into demand. We have values for intercept and slope because what we want to determine inside of the production planning model is also the price. So I expanded, I put an extra row in, call it price, P of T, for T is time, and I just stubbed in $8. Now the demand is now not constant. It depends upon the parameters of the demand model. And so I put the parameters over here in M and N, right? You can see I have already designated these cells with named ranges, intercept and slope. You can see that over on the left here. So that's pretty fine. And you can see also that they come from demand D6. And I guess when I dropped it in, it kept that A1 designation. Okay, some cleaning up is definitely going to be needed. Everything else looks pretty much the same. Okay, how did I expand this? Okay, first of all, let me put in production. I don't even know what production is here. I have to solve for it, as well as for the price. And I really want to go and do this for several weeks. I have 9 weeks here. You can choose whatever. We originally had 6. 13 weeks is a quarter. Not a bad thing to choose. I made the period numbers. Look what I did. I didn't write them in. I used a formula, which is good practice, prevailing recommended practice, we used to call it. And beginning inventory, well, this is starting still with 7,000. We have beginning inventory. We have demand and production, and you get ending inventory. None of that changes. And the ending inventory of period 1 becomes the beginning inventory of period 2. Okay, that's the model, very straightforward. And you just copy that all the way across. Okay, so when you expand, what I mean by that is this. Go to home, go to insert, go to columns. Created a new column. You have to start doing things like this. And of course, now this, when you insert a column, things change. 4 will refer back, G will refer back to E. Okay, so you just have to copy this all the way down. Now I have 10. Okay, beginning inventory. Do the same. Copy it all the way down. And that will preserve the integrity of that part of the model. Demand. I just stubbed in $8 just to make the demand number work. You have to copy it all the way down to L. Okay. And the same with the calculation for inventory, which is the key constraint in the whole model, actually. Minimum production, I'm just going to use whatever here. I don't know what to put in. I'm just playing with the numbers right now. I did not specify that in the case. That's up to you. Oh, there we go. And average inventory. There we go. I had to change every single one of those values. So I had to copy them all the way through. If you don't do this, this will not work. And I can expand this one more, or 5 more, or 20 more. Won't matter. It's all the same model. And finally, down here, look at these calculations. Now, there's nothing here. Look what happens when I do this. These come up 0, so you're going to have to put in numbers. I mean, you can just put in the previous number. That's fine. It's an assumption of the analysis, just to make the model work, which is all I really want to do right now. Just want to make the model work. And here I need to do the same. There we go. Will the model work? I have no idea. Everything else is basically the same. All I did was expand the columns, make sure that my calculations are clean. They follow cell by cell. They don't jump because I had to expand the columns. Now, the next step of this potentially laborious reuse process of the model is to go to data ribbon, over to the analysis box, to solver, and see what kind of a problem we have there to solve. Okay, here we go. Now, squinching down, I'm basically going to reset many of these, but that appears to be correct. Set objective, N13, N15. Yes, that's correct. Blue is still preserved. Look what else gets preserved. This is lovely. Changing cells, variable C to L. That's good. I have to put a comma in here in order to write in the price decision, because that's the other decision we're making here. Okay. C to L, C to L, C to L. Oh, that's wonderful. But this doesn't work. It only goes to I. Let's change that. Can you see that? It only goes to I. Now that's correct. That hits price production is less than or equal to max. You can see it only goes so far. C10, there we go, that's correct. Okay, so let's rewrite that one. There we go. That's now correct. Say okay. And now let's also look at the next one, which is the min production. It goes from C to L. And this only goes from C to I. They have to go the same length all the way. There we go. Now that's correct. Okay, good. Do we have any other gaffs here? Oh, C7, what's that? Wish I could comment these. It's painful that we can't. I got to go back and look at what C7 is. C7 is C to L is the inventory constraint. We have two inventory constraints. One is a safety stock that's at N7, has to be greater than, that's a requirements. Greater than or equal to is always a requirements. It's at least N7, at least 900 here. Here's N7. And a not to exceed is the less than or equal to. Should write that into the readings. Less than or equal to is not to exceed, and at least, that's a floor. It's the greater than or equal to. So those appear to be correct. I don't know if this is going to work. I still want to minimize the cost of inventory. And now I have a pricing decision in this that minimizes cost. I really should have this maximizing profit. But let's try just the pure minimize cost and see if it works. Oh, the little wheel goes around. Objective cell must be a formula. Okay, what objective? Oh, I see. I changed the objective cell without realizing it. It turned it up A. We need to put it back correctly to N15. Not a problem. It's trying to parse it. Oh my gosh. I don't like it when the little wheel goes around and around like that, do you? This is not a big problem, by the way. It's going through many iterations because it's solving for 20 variables. So you can imagine, there we go. It doesn't like it because of a linearity issue. And that's not a problem. I wanted to have this problem, by the way. I'm going to say, okay, and you will get a linearity report. Where is the problem? Occurs linearly. No, no, no. Production and price. Of course they don't. Remember the net present value curve with price? Of course we remember that. Remember, it was the same thing for profit. Profit is some linear function, nonlinear function of price. It's a quadratic equation. Well, okay, we can go back there. And that was very similar to the problem with EOQ. It's a non-linear relationship. Actually quadratic, but it looks hyperbolic, when you take something and divide it by a variant. So let's go back and see if we can fix this. Solver. There we go. Instead of simplex LP, take GRG nonlinear, gradient reducing. And it's trying to solve, it's trying to invert at least a 20 by 20 matrix many, many, many times. So thus the little wheel goes around. We run into this problem with machine learning and AI all the time, which are really optimization problems. Binary classification is the beginning of the problem. And you're trying to see two different areas, and you actually have to figure out the threshold between the two. How do you do that? It's an optimization. Could take a while. Okay, in the nanosecond that I paused and I'm back again, it wasn't a nanosecond. It was about 5 to 10 minutes of Excel shutting down. Don't know why, but it shut down. This is not an unusual occurrence, so you just start back up. I had only saved the 9 version, as you can see, and I had almost everything else in. I actually got this to solve. Let me reset these to a stub of 8. And here's the Excel. There we go. Yeah, it's a prototyping tool. There we go. And we see a total here of 240 if we just held everything off like this. So, I mean, we could tweak this interestingly. We can put bounds on prices as well. But right now, I just wanted to get it to solve, and then I'll start playing with it. As you can see here, each of the constraints goes from C to K. C to K, that's the minimum and maximum production constraint. And the two operative inventory constraints also go from C to K to their respective right-hand side. And remember, again, I will reemphasize this, a greater than or equal to is a requirement. A less than or equal to acts like a budget and not to exceed in a contract. I have switched this to GRG nonlinear because, as I said before, one of the decision variables, price, is literally a quadratic equation mathematically, but it's nonlinear. Okay, it causes costs to be nonlinear. Okay, because of this, we get a demand. We don't specify that. Look at all the demand is equal here, so we know the equation is working. Make sure that you copy all of these across to K. And now I'm going to solve. You can see it solves pretty quickly. Obviously, the spinning wheel was a problem in the background. I probably had a fatal conflict in the underlying Excel platform. Can we get a sensitivity? Sure, I want to see a sensitivity. And it's there somewhere. There we go. Sensitivity report. Deuce gradient, I don't need. I do need a multiplier. Only one of the many constraints has a very small Lagrange multiplier. So this is solving straight for the throat. Still 346. $8 is what it's solving to. It's a very straightforward optimization. It works. Not going to worry about that. Now I'm going to start playing with it. What this basically says is keep price constant. Also, production is following very closely the minimum production line. Okay, the minimum production. So this is a very, very conservative model. I would challenge you to come up with other scenarios. And we start coming up with other scenarios. You might put a how likely is that scenario number against the scenario outcome of cost and decisions being done. And that's what we're going to be doing next week with simulation. Simulation will introduce one more layer of intelligence on top of these models, like how often a scenario. We just did one scenario. That's all we've done. Okay, I'm going to leave you with that. Enjoy your weekend. Holler. Don't write me an email. Write it on the wall. This is a collaborative learning environment. If you write me an email, I'm going to respond to you. But what will happen is I'll also require you, because it's participation in the class, to put your concerns on the wall. And we all have concerns. We all have to have that very deep intellectual humility. I mean, mine is assailed all the time. I think I know something when I really don't. And we can literally not outsource, but we can collaborate and cooperate with one another. And sometimes the insight can generate a little bit more quickly because it's just one little thing we needed to understand before we got to complete understanding on the solution to a particular problem. That's how the human mind works. It works a little bit more like the beehive than by ourselves. Okay, I'll leave you with that, and thank you very much once again for your very, very kind attention.